let's do some examples. So we have f of x is equal to 3x to the fourth times x minus 1 squared times x plus 5. We're asked to determine a bunch of the following characteristics about this function. We first have to figure out what type of polynomial do we have. Here, because we have parentheses, we know that we have factored form, and that's going to come into play when we find the degree. Because our degree needs to be found for the factored form, we're going to add all of the exponents on the variables. If we look at our exponents, we have 4 plus 2 plus the imaginary 1 hanging out on the x plus 5, which means that we have a degree of 7. The number of x-intercepts is the same as the degree, which means that we have 7 x-intercepts. The maximum number of turning points is found by taking n minus 1. We said n, our degree was 7, minus 1 gets us 6 turning points. And keep in mind that is the maximum. We're not guaranteed to have 6, but 6 is the absolute maximum number that we can have. End behavior. Remember, end behavior is all determined by your leading coefficient and whether your degree is even or odd. So if we look at our A, our leading coefficient, in this case is 3, which is positive. Because it is positive, that means on the right side, we go up. Yeah, because we're ending on a positive note. Our degree is 7, which is odd. And that means that our arms are opposite. They go in opposite directions. Since my right side is rising, my left side must fall. So my end behavior is that we fall left and we rise right. So start with identifying whether A is positive or negative. That tells you what the right side does. Negative goes down, positive goes up. And then use whether your degree is even or odd to find out what happens on the left. Part E, we're asked to find all zeros and their multiplicities. I'm going to zoom out just a little bit so I can see the entire problem. Since we have factored form, we're going to take each of our factors and set them equal to 0. So 3x to the fourth equal to 0, x minus 1 squared equal to 0, and x plus 5 to the first equal to 0. You don't have to write to the first, but you can. If we're solving our first equation, we would divide by 3. 0 divided by 3 is 0. And if we take the fourth root of both sides to get x by itself, we find out that x is 0. If we have x minus 1 squared equal to 0, we could use the square, but that really just means that x minus 1 is equal to 0 because the square root of 0 is 0. And we find out that x is equal to 1. And then we have x plus 5 to the first equal to 0. That means that x plus 5 is 0, or x is equal to negative 5. So we have 3 distinct or separate or individual x-intercepts. And you may be thinking, wait, our degree is 7. You said we had 7 x-intercepts. We only found 3. That's where their multiplicities come into play. Remember, in factored form, our multiplicities come from our exponents. We had an x to the 4th, which means x to 0 has a multiplicity of 4. We have x equal to 1. Its exponent is a 2 on our parentheses, which means that his multiplicity is going to be 2. So we have x equal to 1 with a multiplicity of 2. For our x equal to negative 5, that came from x plus 5 to the first, which means that our multiplicity is going to be 1, because that is the exponent on his factor. And if you add up all of our multiplicities, 4 plus 2 plus 1 gets us 7, which means that we found all of the x-intercepts. We have 3 distinct or separate x-intercepts, and then the multiplicities, how many times we see them, makes up our degree. We need to determine the behavior of the graph at the zeros. We're not talking about end behavior. End behavior is rise and fall. Behavior at the zeros is either touch and turn, which remember you can also call bounce, or cross. You touch and turn if you have even multiplicity. We cross when we have odd multiplicity. Okay? So we touch and turn and we cross. With these multiplicities, we're going to use them to put them into the categories, but make sure you pay attention to the x values. So for x equal to 0, multiplicity of 4, 4 is even, which means at x equal to 0, we touch and turn. Notice I didn't write down the 4, I wrote down the x equal to 0. Let's go to the next solution. X equal to 1 has multiplicity of 2, which is even, which means x equal to 1, the graph touches and turns. Even though 1 is not even, his multiplicity is, and that's what matters. But again, I didn't write down 2, I wrote down my x value. And for the last one, x equal to negative 5, he has multiplicity of 1, which is odd, which means that our graph crosses at x equal to negative 5. Last one for this problem. We need to find the y-intercept of the function. Remember that this means that we need to plug in x equal to 0 in our function. Anytime we see an x, we're going to put a 0. So f of x becomes f of 0. We have 3 times, instead of x to the 4th, we're going to have 0 to the 4th. Times 0 minus 1 quantity squared times 0 plus 5. And we don't have to write to the first. Now, if you want to do an intermediate step, you would have 3 times 0, because 0 to the fourth is 0, times 0 minus 1 gets us negative 1 squared, and 0 plus 5 gets us 5. Now, you could go through and do that intermediate step or put this all into your calculator at once, but either way, you should wind up with 0 for your y-intercept. And if we need to write the ordered pair, we just found our y-intercept is 0, which we plugged in for the x, comma, 0, which we found for the y.